Hello, and we are back looking at problem 1.11. Draw a line bond structure for 3 butadiene. Now, what's unusual about this problem is that they're throwing a curveball at us that involves some nomenclature that we have not yet learned. But I'd like to talk about this just a little bit without really getting into it too much, because this is going to be something obviously we're going to get into in a chapter or two from here. But since they've already thrown this at us, why don't we sort of give it a shot anyway and see what we come up with. This 1 and 3 are saying that if we had something like this, where we've got a carbon, a carbon, a carbon, a carbon, and a carbon, at the first, let's write this out. Let's leave it at that, actually, because that's more like what it looks like. At the first and third carbons, this guy and this guy, there's something going on. And whatever it is, by the 1 and the 3, that's what it's trying to tell us, that something at this carbon and this carbon is happening. The buta means 4 carbons total. So something at the 1 and the 3 carbons out of 4 carbons total in a diene molecule, which, by the way, means double bond, and there is 2 of them. So 2 double bonds is diene. So let's go ahead and draw out the line bond structure for this molecule. What we're looking at here, and first of all, I guess I should write this out. H2C double bond, CH, single bond, CH, followed by a double bond again, and a CH2. These guys on the ends, CH2 and H2C, obviously are the same, and these two in the middle are obviously the same. Okay, let's go ahead and draw this guy. So right here, this guy here, what we have is a carbon with 2 hydrogens branching off, leading into a carbon and a hydrogen. That leads into another carbon and another hydrogen. And finally, we have our last carbon with 2 more hydrogens on the end. It's a mirror image of itself. Okay. By the way, this guy and this guy, these 2 double bonds right here, that's where you get this from. Okay. Now we got to hybridize this guy. Let's take a look at it. What do we see? Well, just by looking at it, I can see that we have this, which if you flip this around, if you rotate it 90 degrees, let's say to the left, what you have is this. And this represents a trigonal or trigonal planar. And the bond degree is 120. Okay? Moving right along, going to the other side of this guy here, we've got the same thing, don't we? So now we've got ourselves 2 trigonal planars. All right? Let's look at this one and this one. What do we have here? We've got a carbon in the center. We've got a carbon over here to the left, connected with a double bond. And we've got a carbon to the right with a single bond and a hydrogen above it. So if we were to take this guy right here, okay, and we were to, let's say, rotate him 90 degrees to the right where this carbon is on top. Let's go ahead and do that. That would end up giving us something like this. The hydrogen at the top would be there, and this carbon here, let's say, would be down here. Okay? And in reality, you would end up having something more along the lines of a carbon down here and a hydrogen up here, because the carbons want to stay next to each other, as do the hydrogens. That's just the way these things operate. So even though I did flip it over, and that's the way it would have been if I had just rotated 90 degrees, In actuality, this is more what it would look like. And once again, we have ourselves a 120 degree trigonal planar. Okay. I believe that is all with this problem. Let me just read it and see if there's anything else that they would like us to do. We predicted the bond angle. We have hybridized each one of these carbons. You've got trigonal planar, trigonal planar, trigonal planar, and trigonal planar. This guy here, by the way, even though I didn't draw it out, is the same as the one to his left. Only you would do the opposite. Instead of rotating it at 90 degrees to the right, you go ahead and rotate it 90 degrees to the left. But other than that, you do have the same thing there. Okay? And that's it. Looks like we're done on that one. We'll see you on the next one.